What is the maximum value of the function sin x plus cos x? Here we have to find maximum value of the function sin x plus cos x. Here interval is not given. So we have already found it. Okay, let's see. Let's apply second derivative test. F of x is equal to sin x plus cos x. Okay, what is f dash of x? F dash of x is equal to cos x minus sin x. Then f dash of x is equal to 0 implies cos x minus sin x is equal to 0. That implies cos x is equal to sin x. So what is the values of x? X is equal to pi by 4. Okay, x is equal to pi by 4. So here let's find what is f of pi by 4. Okay, it is the critical point and no need to check. Here we have to find the maximum value. This function has maximum value at x is equal to pi by 4. Here we will get f double dash of x is equal to f double dash of x is minus sin x minus cos x, that is equal to minus of sin x plus cos x. Okay, then what is f double dash of pi by 4? That is equal to minus of sin pi by 4 is 1 by root 2 plus 1 by root 2, that is equal to minus root 2, that is less than 0. Therefore this function has maximum value at x is equal to pi by 4. Okay, so what is the maximum value? Here we have to find what is the maximum value of this function. That is nothing but substitute x is equal to pi by 4 in f of x. Okay, so maximum value is equal to f of pi by 4, that is equal to sin pi by 4 plus cos pi by 4, that is equal to 1 by root 2 plus 1 by root 2, that is equal to 2 by root 2, that is equal to root 2. So root 2 is the maximum value of this given function sin x plus cos x. Find the maximum value of 2x cube minus 24x plus 107 in the interval, closed interval 1 to 3, and find the maximum value of the same function in closed interval minus 3 to minus 1. Okay, first we will find in this interval, case 1. Okay, so our f of x is equal to 2x cube minus 24x plus 107. Okay, so here for both intervals function is same, right? Okay, so first f dash of x is equal to 3 into 2 6x square minus 24, so 6 into x square minus 4, that is equal to 6 into x plus 2 into x minus 2. So f dash of x is equal to 0 implies 6 into x plus 2 into x minus 2 is equal to 0. That implies x plus 2 is equal to 0 implies x is equal to minus 2, and x minus 2 is equal to 0 implies x is equal to 2. So 2 and minus 2 are the critical points. So here first interval, case 1. Okay, so here the interval x belongs to 1 to 3. Okay, so here least value of x is 1 and maximum value of x is 3, right? So let's find f of 1. F of 1, yes, here x is equal to minus 2 is not possible, okay, because here x belongs to closed interval 1 to 3, so only the integers 1 to 3, that is 1, 2, 3, okay, integers 1, 2, 3, but minus values are not included in this interval. Therefore x minus 2 is not possible, so only x is equal to 2. Okay, so f of 1, let's find one by one values of the function. F of 1, the least value of x is equal to 1. So f of 1 is equal to, substitute x is equal to 1 in f of x, 2 into 1 cube minus 24 into 1 plus 107, that is equal to 2 minus, say 2 plus 107, 109 minus 24 is 85. Then f of, next value is f of 2. Okay, f of 2 is equal to 2 into 2 cube minus 24 into 2 plus 107. Here 2 cube 8, 16, 107 minus 48. This will be minus 24 added, here 8 added, right? That is 75. So f of 3 is equal to 2 into 3 cube minus 24 into 3 plus 107, that is equal to 89. Okay, so here we have got three values. So we have to find the maximum value. Okay, maximum value of the given function in the interval, closed interval 1 to 3. So here what is the maximum value among these values? Maximum value is 89, right? So here the maximum value is in this interval. Okay, maximum value is equal to 89. That is maximum of these values. So 89. Then next we have to find maximum value of the same function in this interval. That is case 2. Here next case, x belongs to case 2, x belongs to minus 3 to minus 1. See here the critical points we have got, see we had got x is equal to minus 2 and x is equal to 2, right? But here in the second case minus 2 belongs to this interval. Okay, minus 2 belongs to this interval, but 2 does not belong to this interval, right? So here we have to take x is equal to minus 2. Okay, so here first of all, what is the least value of x? Minus 3 is the least value, right? So let's find f of minus 3. That is, substitute x is equal to minus 3 in f of x. 2 into minus 3 cube minus 24 into minus 3 plus 107, that is equal to, here after calculation you will get 125. Then next we will find f of minus 2, because here minus 2 belongs to this interval. Okay, our interval is minus 3 to minus 1. So what are the integers? Minus 3, minus 2, minus 1, right? So here minus 2 is included, but 2 does not include. Okay, so here f of minus 2. So 2 into minus 2 cube minus 24 into minus 2 plus 107. Okay, that is equal to, see here you will get 139. Okay, then let's find f of, so what is the maximum value of x? Minus 1. f of minus 1 is equal to 2 into minus 1 cube minus 24 into minus 1 plus 107, that is equal to 129. Okay, so here what is the maximum value? Here our question is find the maximum value of the same function in this interval. Okay, that is, here maximum value is maximum of these values. So what is the maximum value among these values? 139, right? So 139 is the maximum value of this function. It is given that at x is equal to 1, the function x raised to 4 minus 62x square plus ax plus 9 attain its maximum value on the interval, closed interval 0 to 2, find the value of a. Okay, so here already given at this point the function attains maximum. Okay, so here what is the function? F of x is equal to x raised to 4 minus 62x square plus ax plus 9. Okay, then what is f dash of x? Here what we have to find? We have to find the value of a. F dash of x is equal to 4x cube minus 124x plus a, right? Okay, so here it is given that this function a attains maximum at x is equal to 1. Okay, see, by the second derivative test we know that If C is, say, that is, if the function has a maximum value at x is equal to C, then f dash of C is equal to 0, right? See, from that only we find the critical values, right? F dash of x is equal to 0, that implies x is equal to, that is the critical values, means f dash of C is equal to 0. Okay, so because here it is given the function attains maximum value at x is equal to 1. Okay, therefore f dash of 1 is equal to 0, right? So here we can write, since the function f of x attain its maximum value at x is equal to 1, so f dash of 1 is equal to 0 by the second derivative test. Okay, so f dash of 1 is equal to 0, because we know that the second derivative test is, so if the function has a maximum value at x is equal to C, then f dash of C is equal to 0 and f double dash of C is less than 0, right? So here f dash of 1 is equal to 0, because this function attain maximum at x is equal to 1. Therefore f dash of 1 is equal to 0. Okay, so this implies, see, in this case we can find the value of a. F dash of 1 is equal to 0 implies, what is f dash of 1? 4 into 1 cube minus 124 into 1 plus a, that is equal to 0. That implies 4 minus 120 plus a is equal to 0. That implies, see, 124, okay. So it will be minus 120 is equal to minus a, that implies a is equal to 120. So we have got the value of a, that is 120. Okay, so we have found the answer already. But here let's check this function attains maximum or minimum. Okay, so we will find f double dash of x. What is f double dash of x? That is 12x square minus 124. Okay, so at this point, which point? At x is equal to 1, what is the sign of this f double dash of x? Less than 0 or greater than 0? We should get less than 0. Okay, so here f double dash of 1 is equal to 12 into 1 minus 124, that is equal to minus 112. Okay, that is less than 0. Okay, so here we can confirm this function has a maximum value at x is equal to 1 and the value of this a is nothing but 120. Okay, therefore value of a is equal to 120. Find the maximum and minimum values of x plus sine 2x on closed interval 0 to 2 pi. See here, the maximum and minimum values of the function means absolute maximum and absolute minimum values of the function. Okay, in this case, see, we have to find the values of the function at not only critical points. Okay, we have to find the values of the function at these points also, because here we will find the absolute maximum and minimum value. Okay, that is the maximum value and minimum value. But see, if you are asked to find the local maximum and minimum, see, you have to apply, you can apply second derivative test. That means we have to find the only values of the function at the critical points, right? But here in this interval, when interval are given, we have to find the values of these intervals. Okay, that is here we will find f of 0, then f of 2 pi. In these values, what is the maximum value? Okay, so here let's find, first of all, let's write given function f of x is equal to x plus sine 2x. Okay, then f dash of x is equal to 1 plus cos 2x, right? 1 plus cos 2x into 2. So 1 plus cos 2 cos 2x. So f dash of x is equal to 0 implies 1 plus 2 cos 2x is equal to 0. This implies 2 cos 2x is equal to minus 1. This implies cos 2x is equal to minus 1 by 2. See, when cos is minus 1 by 2, we know that cos pi by 3 is 1 by 2, right? Cos pi by 3 is 1 by 2. Here when cos is minus 1 by 2, see here, what about 3 pi by 3? See, cos 3 pi by 3. 3 pi by 3 is cos pi plus pi by 3, right? Pi minus, yes, pi minus pi by 3. Okay. See, pi minus cos pi minus means lying in second quadrant. In second quadrant, cos is negative. Therefore, minus cos pi by 3. And we have cos pi by 3 is 1 by 2, right? Cos pi by 3 is 1 by 2. We need when cos is minus 1 by 2. Okay. So here cos 3 pi by 3 is, we have got minus cos pi by 3, that is minus 1 by 2. Okay. So when this implies 2x is equal to 3 pi by 3. Then next 4 pi by 3 is possible. See, 4 pi by 3 is nothing but pi plus pi by 3, right? So pi plus pi by 3. So what is pi plus pi by 3? Cos pi plus. Pi plus means in third quadrant. In third quadrant also minus, cos is minus. Yes or no? Yes. Okay. So here minus cos pi by 3. So it will be minus 1 by 2. So 4 pi by 3 is. So and you have to check whether these points are belongs to this interval, given interval. Okay. So you obviously this one, these 3 pi by 3, 4 pi by 3 belongs to this interval. Okay. So next, what about 5 pi by 3? See, 5 pi by 3 is nothing but 2 pi minus pi, right? Cos 2 pi minus pi by 3, that is equal to, see, 6 pi minus pi, that is 5 pi by 3. Cos pi by 3. 2 pi minus means fourth quadrant. Okay. See, if it is 2 pi. See, 2 pi minus means fourth quadrant. We know that in fourth quadrant cos is plus. So it will be cos pi by 3, that will be plus 1 by 2. So 5 pi by 3 is not, right? So here next 6 pi by 3. What about 6 pi by 3? 6 pi by 3 is nothing but 3 pi, right? So 3 pi is cos 3 pi is minus 1. So next 7 pi by 3. 7 pi by 3 is 2 pi plus pi. So it will be in first quadrant. In first quadrant all are positive. So it is not. So it will be cos pi by 3. That will be plus 1 by 2. Okay. So next is 8 pi by 3. See, 8 pi by 3 is nothing but 3 pi minus pi. Okay. See here it is 2 pi. Then 3 pi is nothing but this one. Right. It is 3 pi. So 3 pi minus means second quadrant. In second quadrant cos is negative. Therefore it will be minus cos pi by 3. So that is minus 1 by 2. Therefore 8 pi by 3 is possible. Okay. Next 9 pi by 3 is 3 pi itself. So next is 8 pi, then 10 pi by 3. So what about 10 pi by 3? 3 pi plus pi by 3. So it will be third quadrant. In third quadrant cos is negative, so it will be minus 1 by 2. Therefore 10 pi by 3. Okay. After that 11 pi by 3, that is 4 pi minus pi. So 4 pi minus pi, it will be 4 pi minus. 4 pi minus means in fourth quadrant it will be positive. So 11 pi is not. 12 pi by 3 is 4 pi, that will be plus 1. Then after that 13 pi by 3, so it does not belong to in this interval. Okay. So here, yes, 13 pi by 3 means 13, that is 4 pi plus pi. It will be in first quadrant. It belongs to this interval, but it is 1 by 2, plus 1 by 2, not minus 1 by 2. Therefore it is not possible. Okay. So after that 12 pi by 3, that is 2 pi. So cos 2 pi is 1. Okay. Then after that 13. So after that these points, after that points does not belong to this interval. So the 2x is equal to 2 pi by 3, 4 pi by 3, 8 pi by 3, 10 pi by 3. So what is x? So x is equal to here 3 pi by 3. Sorry, it is not including, right? So 3 pi by 3 is nothing but pi, right? Cos pi is minus 1. So what about the 2 pi by 3? 2 pi by 3, okay? So it is, sorry, 2 pi by 3 is equal to cos pi minus pi by 3. Okay, that is 3 pi minus pi. Okay, so for second quadrant, okay, cos pi minus, that will be lying in second quadrant. In second quadrant, cos is negative, so it will be minus cos pi by 3, that is minus 1 by 2. Okay, so 2 pi by 3, not 3 pi by 3. 3 pi by 3 is nothing but pi itself, right? Cos pi is minus 1. Okay, not minus 1 by 2. So here 2 pi by 3 divided by 2 is pi by 3. Then 4 pi by 3 divided by 2 is 2 pi by 3. 8 pi by 3 divided by 2 is 4 pi by 3. Then it is 5 pi by 3. Okay. So these are the critical values. Okay. Then let's find the values of the function one by one at these points. Okay. And 0, 2 pi. Okay. 0 is the least value of x. So first of all, let's find f of 0. So f of 0 is equal to 0 plus sine 0 is 0, that is equal to 0. Okay. Then next we will find f of pi by 3. F of pi by 3, f of pi by 3 is equal to pi by 3 plus sine 2 pi by 3. What is sine 2 pi by 3? That is equal to pi by 3 plus, see, sine 2 pi by 3. We know that sine pi by 3 is root 3 by 2. Okay, sine pi by 3 is root 3 by 2. Sine 2 pi by 3 is nothing but sine pi minus pi by 3, that is 2 pi by 3, right? So sine pi minus means second quadrant. In second quadrant, sine is positive, therefore it is plus root 3 by 2. Okay, that is sine pi by 3. Okay, it is plus root 3 by 2. Then next f of points are 4 pi by 3. Okay, 4 pi by 3, that is equal to, substitute x is equal to 4 pi by 3 in f of x. So 4 pi by 3 plus sine 2 into 4 pi by 3, that is 8. Sorry, these are the x values. Okay, so we have to find f of 2 pi by 3. That is 2 into 2, 4 pi by 3. So 4 pi by 3 plus, what is sine 4 pi by 3? Sine 4 pi by 3 is nothing but sine plus. Okay, so sine plus, so it will be in third quadrant. Okay, it will be lying in third quadrant. In third quadrant, sine is minus, therefore it will be minus, right? So minus root 3 by 2. After that, f of 2, 4. Yes, 4 pi by 3. That is equal to, x is equal to 2 pi by 3. So 2 pi by 3 minus root 3 by 2. F of 4 pi by 3 is 4 pi by 3 plus sine 8 pi by 3, right? That is equal to, what is the value of sine 8 pi by 3? Sine 8 pi by 3 is nothing but 3 pi minus pi by 3, right? 3 into 3, 9, 9 minus 1, 8. Okay. So here 3 pi, it is 2 pi, so it is 3 pi. 3 pi minus means second quadrant. In second quadrant it is positive, therefore plus 3 by 2. So it will be 4 pi by 3 plus root 3 by 2. Then what about f of 5 pi by 3? That is equal to 5 pi by 3 plus sine 10 pi by 3. Okay, that is equal to, what about 10 pi by 3? 10 pi by 3 means sine 3 pi plus 3 into 3, 9, 9 plus 1, 10. Okay, so 10 in third quadrant, that is 3 pi plus. Okay, it is 3 pi plus means it will be lying in third quadrant. In third quadrant, sine is minus, so it will be minus. So it is 5 pi by 3 minus root 3 by 2. Okay, then after that, last point, that is 2 pi. So what is f of 2 pi? F of 2 pi is equal to, here f of 2 pi is 2 pi plus sine 2 into 2 pi, that is sine 4 pi. We know that sine n pi is 0, therefore its value is 2 pi. Okay. So what is the maximum value? What is the maximum value among these values? See, we have got 0, pi by 3 plus root 3 by 2. and 2 pi by 3 minus root 3 by 2. See, these root 3 by 2 values are very small value, right? That is very near, that is less than 1, right? Root 3 by 2 is less than 1. So here, see, it is 4 pi by 3, 5 pi by 3. See, our one more value is 2 pi. See, among these values, 2 pi is the maximum, right? See, because, see here 5 pi by 3 means, see, if it is 6 pi by 3, it will be 2 pi, right? And minus root 3 by 2, that is also less than, right? The less than 2 pi. So here we can say 2 pi is the maximum value among these values, right? Therefore, maximum value is equal to 2 pi. Okay, that is maximum of these values. Maximum of 0, pi by 3 plus root 3 by 2, 2 pi by 3 minus root 3 by 2, and 4 pi by 3 plus root 3 minus 2, root 3 by 2, 5 pi by 3 minus root 3 by 2. So 2 pi. So 2 pi is the maximum. Okay. Then what is the minimum? See, no doubt minimum is 0, right? So minimum value of this function is 0. Minimum value is equal to 0. That is, minimum of these values is 0. That is minimum of 0, and these values of the function is nothing but 0. Therefore, we have what? My minimum value of the function is 0 and the maximum value of this function is 2 pi. Find two numbers whose sum is 24 and whose product is as large as possible. So here we have to find two numbers. Their sum is 24 and their product, we have to find two numbers whose product is as large as possible. Say for example, let's take one example. Okay, so here sum of two numbers is 6. Okay, we know that 1 plus 5 is 6, right? So 1 plus 5 is equal to 6. So what is 1 into 5? That is 5, right? And possibilities 2 and 3, right? 2 plus 4. 2 plus 4 is equal to 6. But 2 into 4 is 8, right? And next 0 plus 6 is equal to 6. 0 into 6 is equal to 0. Then see here, we have to find the two numbers whose product is as large as possible. See here, what is the large number? That is, greatest number is 8. So therefore, here the two numbers are 2 and 4. So similarly, here we have to find the two numbers whose sum is 24 and their product is as large as possible. Okay. So here we have to find the maximum value. See, maximum value of which one? That is product of two numbers. Okay. So first of all, let x and y be two numbers. Okay. Let x and y be two numbers. Then we know that x plus y is equal to 24. X plus y is equal to 24. Okay. That implies y is equal to 24 minus x. Right. See here, what we have to find? See, we have to find the maximum value of product of these numbers. Okay, maximum value of product of these numbers. So here function is nothing but product of these numbers. Okay, because we have to find, see, the two numbers whose product is as large as possible. That means here we have to find the maximum value of product of these numbers. That is x into y. Okay, if x and y are two numbers, then x into y is the product. So product of two numbers is equal to x into y. That is, x into y is 24 minus x. That is equal to 24x minus x square. So it is our f of x. Okay, f of x is equal to 24x minus x square. Okay, now here let's apply second derivative test. No interval is given. Okay, so we have to apply second derivative test. For that, let's find f dash of x. What is f dash of x? F dash of x is equal to 24. Derivative of 24x is 24 minus 2x. Here 2 is common, so 2 into 12 minus x. Okay, so f dash of x is equal to 0 implies 2 into 12 minus x is equal to 0. That implies x is equal to 12. Okay. So x is equal to 12. Now let's take, okay, its second derivative means f double dash of c. That is f double dash of 12 less than 0 or greater than 0. We should get less than 0 for maximum, right? Because here we have to find the maximum value, right? That means maximum, this product is as large as possible, okay? So here let's find f double dash of x. F double dash of x is equal to, here it is our f dash of x, right? This one, okay. So here 24, derivative of 24 is 0. So minus 2 is the f double dash of x, that is less than 0, right? So f double dash of 12 is also less than 0. So here we can say this function is maximum. This function has a maximum value at x is equal to 12. Okay. So here one value is x is equal to 12. Okay. So this function f of x attains maximum value at x is equal to 12, and the x is equal to 12. Therefore here y is equal to, x is equal to 12. So the two numbers are x is equal to 12, and if x is equal to 12, what is y? Y is equal to 12. Y is equal to 12. Okay. Then their product is nothing but, so what is the maximum value? Substitute x is equal to 12 in this given equation. That is given function means x into y, 12 into 12, that is 144. So 144 is the maximum product of these numbers. So here we have to find only two numbers, that is x is equal to 12 and y is equal to 12. Two numbers are x is equal to 12 and y is equal to 12. Find two positive numbers x and y such that x plus y is equal to 60 and x into y cube is maximum. See here also we have to find two numbers whose sum is 60 and the product of one number and cube of another number is as large as possible. Okay, that means x into y cube, if x and y are two numbers, x into y cube is maximum. So here we have to find the two numbers when x into y cube is maximum and their sum is 60. Okay, so here what is our function? It is our function, right? So here x plus y is equal to 60, that implies y is equal to 60 minus x. Okay, so what is our function? F of x is equal to x into y cube, that is equal to x into 60 minus x whole cube. Okay, so it is our x cube, sorry, f of x. F of x is equal to x into y cube is equal to x into 60 minus x whole cube. Okay, so f of x is equal to x into 60 minus x whole cube. Okay, this function should be in x. Okay, so here let's find f dash of x. Okay, here also we will apply second derivative test. F dash of x is equal to, apply product rule, x into derivative of 60 minus x whole cube, 3 into 60 minus x into minus 1, right, whole square. Okay, plus second function, that is 60 minus x whole cube into derivative of x is 1. Okay, that is equal to, see here in this 60 minus x whole square is common. Okay, two terms are here. In two terms 60 minus x whole square is common. So let's take it out, 60 minus x whole square. So here remaining minus 3x plus 60 minus x, that is equal to 60 minus x whole square into 60 minus 4x. Okay, so next set f dash of x is equal to 0. That implies 60 minus x whole square into 60 minus 4x is equal to 0. That implies x is equal to 60 and 60 minus 4x is equal to 0 implies 4x is equal to 60. 4x is equal to 60 implies x is equal to 15. Okay, so x is equal to 60 and x is equal to 15. Okay, See, when x is equal to 60, what is the value of y? Y is equal to 0, right? So, okay, let's find the second derivative, okay, f double dash of x. So, in these critical points, what is the f double dash of x, less than 0 or greater than 0? Okay, we should get less than 0, right? Okay, so let's find f double dash of x. F double dash of x is equal to, here it is f dash of x, we have to differentiate it with respect to x. So, we have to apply product rule. So, first function 60 minus x whole square into derivative of 60 minus 4x is minus 4, right? Plus second function, that is 60 minus 4x into derivative of 60 minus x whole square, that is 2 into 60 minus x into minus 1. That is derivative of 60 minus x is minus 1. Okay. That is equal to minus 4 60 minus x whole square minus 2 into 60 minus 4x into 60 minus x. See, in both terms minus is common. So, let's take it out. Minus into 4 into 60 minus x whole square plus 2 into 60 minus 4x into 60 minus x. See, what are our critical points? 15 and 60, right? So, when x is equal to 60 means f double dash of 60 is equal to, see, if you substitute x is equal to 60, see here, this term will be 0, this term will be 0. So, totally it will be 0, alright. So, it is not possible, okay, f double dash of 60 is equal to 0. So, next let's check about x is equal to 15, f double dash of 15 is equal to, here, minus of, see, here we will get 60 minus 15, okay, and the values inside the bracket, it will be positive, right, because it is less than 60. This value 15 is less than 60. So, when you substitute x is equal to 15 here, see, this term will be 0, right, 4 into 15, it is 0. So, this term will be 0. So, minus of, here 4 into 16 minus 15, that is 45 square, okay. So, it is always less than 0. That means this function, that is f of x, attains maximum value at x is equal to 15. So, what is the maximum value? What is the product? So, here we have found x is equal to 15. We need to find only two values, okay, two positive numbers. That is, at x is equal to 15, one value is 15 and another value is nothing but 45, right? Because x plus y is equal to 60. So, here x is equal to 15 and y is equal to 45. And what is the maximum value? See, here maximum value is not asked, but here what is the maximum value? X into y cube. So, substitute x into y cube, okay. So, that is 15 into 45 cube. But here we are asked to find only two positive numbers, x and y. So, here in this point the function is maximum at the function attains maximum. Therefore, one value, that is x is equal to 15. Therefore, y is equal to 45. So, 15 and 45 are the required numbers.